Dawn broke over a quiet stretch of German countryside, the fog still clinging low to the fields where, only hours before, the thunder of engines had torn the night apart. A British bomber had gone down fast, silent and strange. When the recovery teams arrived, they expected to find twisted metal, scorched rivets, and shattered steel plates. Instead, they stood in disbelief over something that looked more like the wreckage of a grand piano than a war machine. The aircraft's skin was splintered in layers, the smell of burnt wood and resin thick in the air. Engineers gathered around, confused. They tapped on the fragments, scraped at the seams, and found no familiar alloy beneath. The fuselage wasn't aluminum or steel, it was plywood, a wooden bomber. Some laughed, assuming it was British desperation made tangible, a joke built from furniture wood. But curiosity turned into confusion when they tried to pry it apart. The panels resisted every tool they had. The adhesive that bound the wooden layers was astonishingly strong, almost elastic under stress, yet impossible to separate cleanly. Under magnification, they found that the layers were fused on a molecular level, bonded in a way none of their own materials could replicate. The engineers, silent now, exchanged glances. This was no toy. This was a weapon. Somewhere in Berlin, reports of the discovery began to circulate. A wooden bomber that flew faster than fighters, carried bombs over the Reich, and returned home untouched. To the Luftwaffe's command, it sounded absurd. Hermann Göring himself dismissed it at first, convinced that such an idea was beneath serious attention. But in the ruins of that crash site, among the splintered remains, his engineers had already realized the truth. The British had built something extraordinary, not through industrial might, but through imagination. In the early years of the war, Britain stood cornered, its factories strained under relentless bombing, its supply chains choked by the Atlantic blockade. Aluminum and steel were precious, too precious for experimental ideas. Yet amid the chaos, one man dared to think differently. Geoffrey de Havilland, a visionary aircraft designer, believed that speed, not armor, not guns, would be the key to survival. His proposal to the Air Ministry was radical. A bomber made almost entirely of wood, without defensive armament, relying solely on its velocity to evade interception. Officials were skeptical, even dismissive. Wood belonged in furniture, not in the skies over Europe. But de Havilland persisted. He argued that wood was not only abundant, but could be shaped into aerodynamic forms that metal could never match. And crucially, it would free up strategic metals for fighters and heavy bombers. Working quietly in a modest factory in Hertfordshire, his team assembled a workforce unlike any other in the war. Cabinetmakers, boat builders, piano craftsmen, artisans whose skills had little to do with aviation, but everything to do with precision. They joined engineers and chemists, blending tradition with innovation. Their greatest challenge was not shaping the wood, it was binding it. Ordinary glues couldn't withstand the stress, vibration, and heat of flight. What they needed was something new, something unseen in aviation before. Chemists turned to synthetic resins, adhesives that formed chemical bonds stronger than the wood itself. Through trial and error, they perfected a formula that transformed layers of birch and balsa into a single seamless structure. When the first prototype took shape in late 1940, it was unlike any aircraft the world had ever seen, sleek, light, and smooth as polished sculpture. De Havilland called it the Mosquito. It had no guns, no armor plating, only the promise of speed. The press, when they first heard of it, nicknamed it the Wooden Wonder. Few believed it would even leave the ground. But when it did, on a crisp November morning, it climbed like a fighter and flew faster than any bomber in existence. By 1940, the British aircraft industry was being stretched to its breaking point. Every ton of aluminum, every rivet, every bolt was counted and rationed. Heavy bombers were consuming vast resources, and the country's skies were filled with the metallic growl of machines that were powerful but painfully slow. In that moment of constraint, Geoffrey de Havilland proposed something that sounded almost heretical, to build a combat aircraft not out of metal, but from the same materials used in furniture and musical instruments. The idea seemed laughable to many at the Air Ministry. They wanted armor, guns, turrets, proof of power. A plane without any of those things was, to them, a coffin with wings. But de Havilland saw something they didn't: the possibility of a plane so light, so aerodynamic, that no enemy could catch it in the first place. It would strike like a phantom, faster than radar operators could react, and vanish before interceptors could climb. He was told no more than once. Yet in wartime Britain, where desperation often made room for genius, no eventually became try. And so, in a modest workshop surrounded by green fields, a small team of engineers, craftsmen, and chemists began to build the impossible. There was no assembly line, no roar of heavy machinery, only the sound of hand tools, the smell of sawdust, and the faint sweetness of synthetic resin. The workers were not traditional aircraft builders. They came from furniture shops in High Wycombe, violin makers' studios in London, and boatyards along the Thames. Each brought the precision of a craftsman's hand to a project that few truly understood. The fuselage of the new aircraft was to be molded in halves, using layers of birch and balsa wood pressed together in a smooth, continuous shell. The wooden layers were bonded with a secret mixture, a synthetic resin adhesive that would later become legendary. When cured under heat and pressure, this glue did not merely hold the wood together, it fused it into a new material altogether, something lighter than metal, yet astonishingly strong. Every inch of the Mosquito's frame was shaped by this balance between art and science. The skin of the aircraft wasn't a covering, it was the structure itself, carrying the load, flexing with the forces of flight. The result was an airframe that weighed far less than comparable bombers, and yet could endure the violent stresses of high-speed maneuvers. When the first prototype, designated WWII, rolled out of the hangar, it looked almost delicate. Its unpainted wooden surface gleamed in the sunlight, a warm contrast to the cold, gray machines that dominated the war. There was skepticism in the air, even among the team that had built it. Could something made of wood really survive the fury of combat? The day of the maiden flight arrived on November 25. Geoffrey de Havilland's test pilot, Geoffrey de Havilland Jr., took the controls. The engines roared to life, 2 Rolls-Royce Merlins, the same type that powered the Spitfire. The Mosquito surged down the runway, light and eager, lifting off after a short roll. Within moments, it was climbing effortlessly, slicing through the winter sky with a speed that left everyone on the ground speechless. In the following months, as flight tests continued, the numbers began to astonish even the skeptics. The Mosquito was not just fast, it was untouchable. Without guns or armor to weigh it down, it could outrun enemy fighters with ease. And when radar-guided interceptors finally scrambled to meet it, the wooden bomber was already gone, a ghost that struck and disappeared. This was not just an aircraft, it was a statement. In an age when power was measured in tons of metal, the Mosquito proved that imagination could be a weapon of its own. The heart of the Mosquito's brilliance lay not in its engines or design, but in its materials, and in the people who understood them. The aircraft was born from a partnership between old-world craftsmanship and cutting-edge chemistry. Every piece of wood, every drop of resin, was a product of both art and science. In workshops scattered across Britain, carpenters who once built fine furniture now shaped the skeletons of warplanes. The precision demanded of them was far beyond anything in civilian work. A misaligned seam or an uneven layer could compromise the entire airframe. Yet these artisans, men and women who had never before worked under military contract, performed their tasks with a pride that no factory could replicate. The process was intricate. Sheets of birch veneer were laid over a lightweight balsa core, arranged in alternating directions for strength, then coated with a thin layer of adhesive. The secret glue, developed by the company Aerolite, was a urea formaldehyde resin mixed with a hardener. When heated, it didn't simply stick, it bonded, creating a molecular link between the layers. Once cured, the resulting composite was so strong that attempts to separate it often destroyed the wood before the glue line gave way. This discovery would become the foundation of the Mosquito's myth, the glue stronger than steel. The fuselage halves were molded on concrete forms, then joined at the centerline with precision measured not in millimeters, but in fractions of an inch. Once the shell was complete, it needed no internal frame. It was a single, seamless structure, capable of withstanding extreme aerodynamic stress. Workers sanded the surfaces by hand, sealing them with varnish that gleamed like polished walnut. Inside, the aircraft was minimalist. There was no armor, no gunner's turret, no complex defensive system, just 2 seats, controls and space for a bomb load or cameras, depending on the mission. Every unnecessary ounce was stripped away. The result was an aircraft that embodied pure function, strength through simplicity. As production expanded, the Mosquito became a national effort. Small workshops across Britain contributed parts, cabinetmakers supplied wing spars, piano builders produced instrument panels. Even luxury furniture companies adapted their tools to shape wooden ribs and fairings. It was as if the entire tradition of British craftsmanship had been conscripted into service. Yet despite its humble origins, the Mosquito represented one of the most advanced examples of aerodynamic design in the war. Its smooth, uninterrupted surfaces created almost no drag. The twin Merlin engines, working in harmony with its light frame, pushed it to speeds exceeding 400 miles per hour, faster than any fighter the Luftwaffe could field in 19. Word began to spread among pilots. The wooden wonder was no myth. It was real, and it was extraordinary. What began as an eccentric idea was now a symbol of quiet defiance. While Germany boasted of its steel and firepower, Britain's secret weapon was built from trees, glue, and imagination, and it was flying circles around the Reich. By the time the Mosquito entered service in 1941, the Royal Air Force had already learned the painful lessons of daylight bombing. Heavily armed aircraft like the Blenheim and Wellington had proven too slow, too exposed. Losses were mounting. Every mission was a gamble. But when the first Mosquito squadrons began to take to the skies, something changed. At first, crews were uneasy. The idea of flying into enemy territory without a single defensive gun seemed suicidal. Pilots were used to hearing the rattle of machine guns behind them, a false comfort in the face of German fighters. Now they had nothing but speed and silence. Their survival depended entirely on the aircraft's design and their trust in it. That trust came quickly. From the first missions, the Mosquito astonished both friend and foe. On reconnaissance runs over occupied Europe, Luftwaffe fighters struggled even to intercept it. The moment radar detected its approach, it was already vanishing. Ground crews soon began calling it the Timber Terror, a ghostly plane that came and went before anti-aircraft guns could even track it. In November 1941, the Mosquito made its operational debut with No. 1 Photographic Reconnaissance Unit. Its cameras captured crystal-clear images of German installations, shipyards, and airfields, all taken from altitudes and speeds no other aircraft could reach. Intelligence officers who examined the film could hardly believe that such results came from an unarmed wooden plane. But reconnaissance was only the beginning. The Mosquito's potential as a bomber quickly became clear. In February 1943, 4 Mosquitoes launched a daring daylight raid on Berlin itself, timed precisely to coincide with a speech by Hermann Göring. As Göring addressed his officers, explosions thundered nearby, silencing the event and humiliating the Luftwaffe chief. He later raged that a ridiculous wooden plane had slipped past every defense to strike the heart of the Reich. From that day forward, the Mosquito's legend grew. It flew precision raids that no other aircraft could attempt. Low-level strikes against Gestapo headquarters, daring attacks on prison walls to free resistance fighters, and high-altitude bombings deep inside Germany. It operated by day or night, in clear skies or overclouded darkness, adapting to every role: bomber, fighter, pathfinder, reconnaissance, and even night intruder. Pilots adored it. The Mosquito responded like a fighter, swift and agile, capable of violent turns that heavy bombers could never dream of. Crews often spoke of it as if it were alive. Temperamental, yes, but always loyal. It could take damage and still bring its men home, gliding silently if its engines failed, its wooden frame refusing to burn or shatter as easily as steel. German pilots feared it. Many Luftwaffe aces admitted later that chasing a Mosquito was an exercise in frustration. Even the fastest interceptors, like the Focke-Wulf 190 or the Messerschmitt 262 jet, found it almost impossible to catch. Its smooth wooden skin absorbed radar waves in ways the Germans didn't yet understand, making detection difficult and interception even harder. In a war dominated by numbers, production, and firepower, the Mosquito was something different, a weapon of elegance and imagination. It proved that survival did not require brute force. Sometimes, the greatest armor was simply to be too fast to hit. From its bases in Britain, the Mosquito's engines carried its crews over the Channel, across occupied Europe, through flak storms and night skies. And as the war dragged on, one thing became certain: the Germans could no longer laugh at the wooden bomber. They could only chase its shadow. By 1943, the Mosquito had evolved from an experiment into a cornerstone of Allied air power. Its wooden wings carried not only bombs but also the hopes of a nation that had once doubted it. Every mission it flew deep into occupied Europe told the same story, that ingenuity could triumph where brute strength failed. The Luftwaffe had long prided itself on technological superiority. Its fighters were fast, its bombers formidable. But the Mosquito shattered that confidence. German pilots spoke with frustration of radar warnings that came too late, of a target glimpsed for mere seconds before it vanished into the clouds. The British bomber didn't fight fair, it didn't fight at all. It simply outran everything thrown against it. On one mission over Norway, a Mosquito reconnaissance crew photographed a German U-boat base and escaped unscathed, though 6 enemy fighters were scrambled to intercept. The Germans never even saw it. Another raid in 1944 on the Gestapo headquarters in Copenhagen became one of the war's most audacious operations. Flying barely 50 feet above the sea, Mosquitoes weaved between buildings and hit their target with pinpoint accuracy, freeing prisoners and destroying records of resistance members. Each mission added to the aircraft's growing mystique. Göring himself, humiliated by repeated failures to stop it, reportedly told his staff, "The British have the geniuses, and we have the nincompoops." For a man whose Luftwaffe once ruled Europe's skies, the admission was bitter. The Mosquito's versatility made it indispensable. As a pathfinder, it marked targets for heavy bombers with flares, its speed allowing it to arrive first and escape before the main force arrived. As a night fighter, it hunted German bombers in the darkness, guided by radar operators who learned to trust its steady, silent power. And as a bomber, it achieved feats that no steel-framed aircraft could match, striking with surgical precision and slipping away unseen. To the Allied pilots who flew it, the Mosquito became a symbol of trust. Its wooden fuselage could take hits that tore through metal planes. Bullets often passed clean through without igniting fires. Mechanics found it easy to repair, patching holes with fresh layers of wood and glue. Even in the field, local carpenters could mend its wounds, an advantage no metal bomber could claim. To the Germans who studied its wreckage, however, it was a source of bewilderment. When a Mosquito finally crashed intact enough to be recovered, Luftwaffe engineers were dispatched to examine it. They expected weakness and fragility. What they found instead challenged everything they knew about aircraft design. When they tried to dismantle the fuselage, the wooden layers refused to come apart. They cut, pried, and burned, yet the adhesive bond held firm. Under testing, it became clear that the glue's tensile strength exceeded that of many metals. The engineers were forced to admit what the battlefield had already proven. The Mosquito's strength came not from steel, but from chemistry. A British aircraft made of wood had outflown, outlasted, and outsmarted the might of the Luftwaffe. By the war's end, over 7,000 Mosquitoes had been built in dozens of variants, serving in every major theater, from the icy skies over Norway to the humid jungles of Burma. It had flown more than 30,000 missions, with a loss rate far lower than any comparable bomber. When the Luftwaffe finally fell silent, the Mosquito was still flying. Its wooden wings, born from necessity and imagination, had proven that innovation, not material, was the true measure of strength. In the final years of the war, as Germany's skies filled with the sound of Allied bombers, Luftwaffe engineers worked desperately to understand how a wooden aircraft could humiliate them so completely. Wreckage from downed Mosquitoes was transported to secret laboratories, where teams of scientists began their dissection. They had studied Spitfires, Lancasters, and American B-17s before, but this was different. This was something they could not easily explain. The first impressions were confusion and disbelief. The Mosquito's fuselage showed no rivets, no weld lines, no familiar seams. Its surface was smooth, curved, and perfectly balanced. The outer layers of birch were thin, but flawless, joined with precision beyond what heavy industry could replicate. When they cut into the structure, the cross-sections revealed alternating layers of birch and balsa, bonded so tightly that they seemed to have grown together like living tissue. The engineers tried to separate the layers, but their tools failed. Even after exposure to heat, moisture, and solvents, the adhesive refused to yield. The strength of the bond was greater than the wood itself. When forced, the layers tore apart, not at the glue line, but within the wood grain. What they were witnessing was a material transformation, chemistry that turned ordinary timber into a composite stronger than many of the metals used in German aircraft. reports filtered up the chain of command. Some dismissed them as exaggerations, but others, those who had touched the wrecks, seen the fibers resist their instruments, knew better. The secret, they concluded, lay in the glue. To German metallurgists and engineers, this discovery was humbling. For years the Reich had placed its faith in steel and aluminum, in industrial precision and heavy machinery. But here was proof that an enemy nation, short on resources, had built an aircraft that defied every assumption about strength and speed. The resin that bound the Mosquito's wooden frame had not only created a stronger bond, it had created a new way of thinking. The aircraft's lightness gave it range, its smooth surface reduced drag, its wooden frame absorbed radar signals, making it harder to detect. Without meaning to, the British had built something that bordered on stealth. Inside Germany's laboratories, engineers conducted experiments to replicate the adhesive. They attempted to create similar synthetic resins, experimenting with phenolic and formaldehyde compounds. But the war was turning against them, resources were dwindling, and the time to catch up had long passed. Their reports, later found by Allied investigators, were filled with reluctant admiration. One described the Mosquito as a masterpiece of aerodynamics and chemistry, and another simply noted, "The wood is nothing, the glue is everything." Meanwhile, Goering's fury grew. Each new raid seemed to mock the Luftwaffe's might. "When I see the Mosquito," he reportedly said, "I am green and yellow with envy. The British, who can afford aluminium better than we can, knock together a beautiful wooden aircraft that every piano factory can build, and they give it speed which outstrips our best fighters." It was the ultimate irony. The nation that had prided itself on engineering supremacy had been bested by carpenters, chemists, and dreamers armed with sawdust and resin. As the war neared its end, captured German engineers would later speak of their astonishment, not just at the Mosquito's design, but at the mindset that had created it. Where the Reich had pursued power through complexity, the British had found victory through simplicity. The Mosquito was proof that true innovation did not depend on what one had, but on what one imagined possible. The phrase "the glue stronger than steel" became more than an engineering observation. It was a metaphor for the spirit that defined the aircraft itself, an idea so bold that even its enemies could only admire it. When the guns of Europe finally fell silent in 1945, the Mosquito was still flying, faster, farther, and more gracefully than ever. It had survived the war, not as a relic of desperation, but as a triumph of innovation. For those who had built it, it was vindication. For those who had tried to destroy it, it was a lasting reminder of how imagination could outmatch might. In the ruins of post-war Germany, Allied engineers pored over Luftwaffe designs, jet fighters, rocket planes, experimental bombers that had once promised dominance, yet none of them inspired quite the same reverence as the wooden British aircraft that had defied them all. The Mosquito had proven that technology was not just about machinery, it was about vision. Its influence stretched far beyond the battlefields it once roamed. The techniques developed for its construction, laminated wood structures, bonded materials, stress-bearing skins, laid the groundwork for the composites that would later shape modern aviation. The same principles would be reborn in carbon fiber and advanced polymers decades later. Engineers who studied the Mosquito in the 1950s and 1960s often called it the ancestor of the composite age. But the legacy of the Mosquito was not only technical, it was human. Thousands of craftsmen, many of whom had never worked in aviation, could look at the aircraft and say, "I built that." In workshops that had once produced furniture and violins, families now built wings and fuselages. It was an act of national creativity, a people turning their ordinary skills into an extraordinary weapon. For the men who flew it, the Mosquito became more than just an aircraft. It was a companion, almost alive. Pilots spoke of its agility, its balance, its quiet confidence. They trusted it in ways they never trusted any other machine. Some called it a plane with a soul. Even after the war, the Mosquito continued to serve, in reconnaissance flights, in the early Cold War, and in distant conflicts, where its speed and simplicity still gave it an edge. Yet no matter how technology advanced, its legend endured. When faster jets took to the sky, pilots still remembered the first time they saw a Mosquito flash overhead, leaving nothing but the shimmer of its passing. Historians often call the Second World War an engineers' war, a conflict defined by production lines, factories, and machines of steel. But the story of the Mosquito stands apart. It was not born from abundance, but from scarcity. Not from industrial power, but from the minds of those who dared to ask, what if we build differently? It was, in every sense, a victory of imagination over industry. And somewhere, in the quiet of a workshop in wartime Britain, perhaps a carpenter once paused between brushstrokes of varnish and thought of the irony that his handiwork, built from wood and glue, might one day fly faster than the world's finest metal machines. When German engineers tore apart the wreck of a Mosquito and found the glue stronger than steel, they were not just uncovering a secret of chemistry. They were discovering a truth about ingenuity itself, that sometimes the most powerful weapons are not forged in fire, but built, patiently, in silence, from the simplest materials of all. The wooden wonder had proven it, beyond doubt, beyond pride, and beyond steel.